In this lesson, we'll complete a top-down view sketch. After completing this lesson, you'll be able to create a sketch mirror, create a link dimension, and create a projection. So let's go ahead and rename the sketch while we're out. I'm going to call this top-down cut, and then I want to go back and edit the sketch. So from this sketch, we've got our 10mm outside wall. We still need to add some offset to this line, and we need to add a bit more information in various areas. We need to add some offsets on the inside as well. So let's go ahead and add a bit more detail. So I'm going to do an offset of this line, and we're going to say that this dimension is 5mm. Now you'll notice that while I'm inside of this operation, it doesn't let me click this. So I'm going to go ahead and just say 5, then I'll double click on it. Sometimes it helps if the constraints are in the way to hide the constraints. And let's go ahead and do another offset. We can say -5, and again we can make it equal. Now one thing you'll notice when we offset a line is because this line ends at a point, what we're actually doing is we're creating a shorter version. Now again, trim or extend, if we use this, it's going to undo that dimension. And you can see that it takes it away. And that's actually okay, but it also undid some additional dimensions. So the way to get around this is, instead of using that offset, is to simply just draw a horizontal line. Now if the line doesn't happen to be horizontal, you can make it parallel, or you can do some additional constraints to make sure that that works. But in our case, they're perpendicular to this vertical line, or a horizontal would be just fine. I'm going to make this one construction. And any center line that I don't need, I'm going to make those construction as well. And that helps with the selection process down the road. Then I want to apply a dimension. So in this case, because I'm in the middle of applying a dimension, I can simply just add it there. And also, if you know the dimension, we can simply type in D19, and it'll be equal to that as well. Under Modify, you can go down into Change Parameters, and you can make universal parameters. They're called user parameters. And you can simply name them ahead of time. So for instance, if you wanted a specific 5 or 10mm offset, instead of having it called D19, we could name it offset. And notice that it re-references all of these to be equal to offset. You could make that ahead of time, or you could name it on the fly instead of being D19. And you can do it that way as well. So that way you don't have to remember D19. All right. So for instance, this 10 right here, we can say that this is offset times 2, and that is equal to 10. So that way, if we ever come back and we change this dimension right here, which is currently 5, if we change it to 6, and then this one will equal 12, and so on. So again, it's just a way to make sure that we're keeping those numbers fairly consistent. All right, so now we've got a bit of structure in the center. We've got the structure around the outside. We've got the structure going to the motors. And again, we don't have to worry specifically about trimming this up. If we trim it, then we will lose some of the offset information because of how the offset tool works. But we can simply leave it long because we can still select these areas. So now we want to add a little bit more. So we need to make sure that we have some structure for the motor that comes to these sides here. And the way that we're going to do that is we're going to carry a line from the center that goes completely out. So again, I'm going to start a line. I'm not going to snap to the midpoint. I just want to snap to the line over here. And the way that I'm going to make this work is I'm going to make it coincident, not in a midpoint relation. And then I'm going to make it perpendicular to this line here. All right. So this is a center line. This is where we're starting our structure. And then we're going to carry a line from this point that's parallel out to the side. So we'll find that intersection point, and it snaps to it automatically. And notice that that's coming out perpendicular automatically, and we can take it out to the wall, and we didn't have to add any additional constraints. Now it's a little bit different when we get out here because we don't have anything to snap to, but I'm actually going to take it and drag it out, and it's tangent, and all I have to do is I need to make these parallel, and it'll fully define it for me. So if I temporarily hide the constraints, you can see what we've done is we've added some structure here And we've added the bulk of this structure here because this is a shorter section. All right, so we're going to have a lot of structure at the center of the quadcopter, and this arm here is quite a bit shorter, so we wanted to carry that structure into the motor as quickly as possible, so it carries it around this corner. And then this one here actually helps provide some additional support to this edge right here. All right, we will be adding some additional structure, so this line, this will be a solid panel area, and this will be a small line here that has some structure to it as well. So keep that in mind, that this is the reasoning for offsetting this in this one way. Now, in general, as we go through our course, we're going to have a section on engineering where we add some more strategic supports. We add some different features to help make sure that this thing is fairly strong. Those types of features will also help us dictate how this thing should work. And again, since I've done this before, I just sort of know that this will work out better and still keep it fairly light. So don't be too worried if you don't understand why some of the design decisions are the way they are. Sometimes it just comes from doing this many times. Sometimes it just comes from experience and so on. We're going to carry on this process on the other side as well. We could mirror this, but sometimes it's just good practice to do it. So if you're new to this and you're new to applying these constraints and dimensions and creating these sketches, it's a good idea to just do it. Just take the repetition as some practice, some experience. So again, find that intersection point. We're going to make these two lines parallel. And then we're going to do the same thing on the back. We're going to come over here. This is tangent, so we're going to make sure that's parallel, and that fully defines it. So that is going to give us some structure for the motor, and it's going to carry that structure right to the center point, and we still need a little bit more. All right, so we're going to have to add a little bit more structure here. We're going to go ahead and we're going to offset this line right here. We're going to not offset this line because we're actually going to leave some of this open in the middle, but we want to carry a line out and we want to offset it in the back so we have a little bit more structure. So I'm going to do this by, first I'm going to draw a line from this to here. I'm going to hit escape. I want to select these two and I want to make them collinear. So what collinear is going to do is it's going to allow me to essentially follow the path of this line without having them connected. So this is going to give me some structure on the backside right here. And we could also just carry it horizontally, but in this case I actually want to keep it going this direction to help with the shape, that X shape that we're going for. So it'll add a little bit more structure to the back as well. And again, using repetition, we're going to follow the same thing up in the front. We're going to use collinear, which we can pre-select if we want to, and we can make these two collinear, and then just make sure that it's deselected once you start modeling again. All right, so at this point, as we're looking at this design, there are a few areas that are going to be open, and there are a few areas that are going to be closed. So this area right here, and this area right here, and this area right there, I'll go ahead and I'll just select them all. All these areas are going to be open. Now this is going to allow the most amount of airflow that we can get without obstructing the prop. Now this area right here is going to be closed off, but it's going to have a minimal thickness sheet right there. So while the majority of this body is probably going to be about 8 to 10 millimeters tall, with some areas that are going to be reduced for weight, obviously. This area right here will probably be 1 to 2 millimeters thick, and it's just for some additional structure. Because of the location of the prop, if we simply just took this brace out and just carried it all the way out here, we would probably have a lot of flex in this area. So we're gonna leave some of this up to the engineer and do some simulations and figure out where the weak spots are. But in general, that is the design process for, or at least the thinking behind why these areas are the way they are. Because we have the circle and we want to make sure that the prop itself can pull as much airflow through there so we don't have any obstructions. We're not restricting the amount of airflow. We're not artificially decreasing our flight time because we're having to use more current to try to pull more air, and we're not getting the ideal thrust. And we're carrying the motor back to the center point of the chassis, and we're also carrying it as close as we can to any additional structure. So at this point, that is going to be the majority of the sketch that we're going to need to start to create some solid geometry. So we're going to go ahead and stop the sketch. We're going to make sure that we save our file. And this is going to give us a great foundation to start creating our solid and surface geometry to start to see how this thing will take shape.